we had seen for a system of particles we are able to define a center of mass where all the mass seems to be concentrated. Okay, but that is our own definition. Fine, that has nothing to do with the motion or whatever of things. So we'll extend this a bit further. We had seen that the center of mass, the position vector of the center of mass, position vector of the center of mass, which is given by r, was actually what? m1 r1. This was the position vector of the point where mass m1 was located, r1, right? So it was m1 r1 plus m2 r2 plus m3 r3 plus mn rn divided by capital M, right? So it was sort of this. So if there is a mass m1, then I am calling this position vector as r1. Okay, and if there is a mass m2 out here, then I have r2, like that. Correct? This is what I am talking about. And we had seen that maybe after we do this, my r vector is here. So this is maybe is the center of mass, and this is where it seems as if all the masses are concentrated. So what is center of mass? Center of mass is the point. Center of mass is the point where all the masses seem to be concentrated. They seem to be concentrated, right? Okay, so and there'll be so many more, right? So there could be say an R3 here and an M3 here at this point, and maybe some R4 here, and at that point we are placed with M4, and fine. Now that gives me that MR is equal to M1 R1 plus M2 R2 plus M3 R3 plus Mn Rn. Is it not? Now if I differentiate both sides with respect to T, differentiating both sides with respect to T, we get, what do we get? M into ddt of R is equal to ddt, actually it is ddt of mr. That can be ejected out. That's what I'll do in the next step. M2R2 plus, okay, obviously M3R3 plus MnRn, and whenever there is a constant, that comes out of the derivative, so it is that, and derivative of sum equals the sum of the derivatives. So what happens? This is equal to d dt of m1 r1 plus d dt of m2 r2 plus d dt of m3 r3 plus d dt of mn rn. Now this is mv is equal to, this also comes out m1 and it becomes d dt of r1, and this becomes m2 d dt of r2, this becomes m3 d dt of r3, and this becomes mn d dt of rn. Now what is that? What is that equal to? So this is equal to m1 v1 plus m2 v2 plus m3 v3 plus mn vn. Correct? Correct? Not yet. Oh, just a sec. Now what happens is this is this. Yeah, it's recording. Wait. Okay. So what happens is that we get that mv is equal to m1 v1 plus m2 v2 plus m3 v3 plus mn vn. Now what does that tell us? That tells us that the total momentum of the center of mass is equal to the sum of the individual momentum of the particles, right? So if I mark it by P, which I reserve for momentum, and I put capital P for that center of mass thing, so that is equal to P1 plus P2 plus P3 plus Pn. So what does it give me? It gives me, first of all, that the momentum of the center of mass is the vector sum of the individual momenta. And secondly, if I want how my velocity, what is the velocity of my center of mass, what do? I sum them and I divide it by m, capital M. Is it not? So it gives me two things. My V is equal to actually P1 plus P2 plus P3 plus Pn upon M. Okay? Upon M. Fine? So from this, which was the equation for the position vector of that, we have been able to track a moving. This was for a stationary one, right? Now if they start moving, how my center of mass moves is given by this. Correct? How my center of mass moves is given by this. And I also know that my momentum for the center of mass, for the particle as a whole, is equal to the sum of momenta of everything, all the individual particles, right? Of the individual particles. of the individual particles. Now, what if I differentiate this? Okay, so I differentiated, this was my first, this is my second equation, and this is my third equation, this is my fourth equation. Now if I differentiate this, okay, differentiating equation 2, differentiating equation 2, we get, what do we get? Again I get the same thing, but I'll not go through so many steps. So it is m dv by dt is equal to m1 dv1 by dt plus m2 dv2 by dt, yeah, with respect to time, plus m3 dv3 by dt plus mn dvn by dt. Now dv1 by dt is a1, and this is a2, and this is a3, and this is an, okay, and this is a. Now this single particle placed here is accelerating, okay, fine. Why should it be accelerating? Due to some force applied on it. For a point mass, we have studied the Newton's second law holds, right? So I know that F is equal to ma. So what happens? This must have risen due to a force F1. Now that force F1 is not necessarily a single force. Here I can allow so many forces to act, okay, so many forces to act. So let us say a force acts like this on this body, and another force acts like that, and say another force acts like this, okay, and say another force acts like that. So in the resultant, okay, in the resultant maybe a force like this is acting here, and it is this force that I call F1. Fine. So it can be a multiple force, any number of forces, they are acting, their resultant is F1. That we know for multiple forces acting at a point, right? Now what happens? So this is equal to F1, is it not? And where F1 can be resultant of so many forces, and this is F2, and this is obviously F3, and this is Fn, okay. So this F I'll not write it as F, I'll write it as Ma, okay, I'll write it as Ma. Now this equation becomes very, very significant. Why? What does it tell me? It tells me, look, these are so many forces which are acting at different points, okay, at the point where M1 is located, at the point where M2, M3, M4, Mn are located. But what is the net effect of that? It is as if that these resultants act at the center of the mass, the resultant of that, So this resultant is F external. Okay, I am neglecting the internal forces. Why? Because all the internal forces, they have an equal and opposite counterpart, and that keeps on cancelling out. So for example, you could say, what about the gravitational attraction between them? That is also there. So what happens to the gravitational attraction? There is one force here, there is another force there. So when it starts summing up, when it comes at this stage, fine, at this stage it will not cancel. But when that component comes here, then it gets cancelled. You understand? Its counterpart from here, that will cancel it. You get the point? Huh? So that F external, so that's why I am calling it F external. Why? Because I am ignoring the internal. The internal force is being ignored. Okay? So here I am ignoring the internal force for the very reason that, so I am ignoring the internal force because they are equal and opposite. So do I erase this? This was M4. So internal forces are ignored because they are equal and opposite. They are equal and opposite, and hence get cancelled. So that's why I say that MA is equal to F external, sum of all the external forces that are acting on the particles. Now this equation is really something that you'll feel is so advantageous to you. It says that, what does it say? It says that, just a second.
सर मतलब फिर सारे masses equal हैं.
It's not that. No. Hold on. What is it telling you? So it seems, what happens? This is the total mass. What is this? Acceleration of center of mass. Okay. Now what happens? It so happens, so equation 5 tells us that all the forces acting at different points, in space, okay, result into a situation where it seems as if they are acting at the center of mass, is it not? So it seems as if they are acting at the center of the mass whose mass is the sum total of all the masses. and as a result of which the center of mass gets accelerated with acceleration A. Again, try to think. When we were doing Newton's, okay, it gave us F is equal to ma, where m was the mass of the particle, a was the acceleration due to the force F. Now what has happened? Though all these forces were acting at different points, now what has happened? This equation tells me that the whole of F external is acting at one point. What is that point? That point is the center of mass. What is the mass of that point? Capital M. What is capital M? Capital M is sum of all the masses. Okay, so it seems as if the resultant of the forces that were acting at different points, the resultant is acting, that one resultant force is acting at the center of the mass, and the center of the mass seems to be holding all the masses. It seems to be holding, though physically obviously the masses are distributed, they are not at that point, but it seems as if they are all at that point, and as a result of this force, the center of mass is accelerating as a point. So what has happened? All that the chaos that I had told you in the earlier class, that there was a big confusion. What happens when I come to system of particles? What happens? Does my Newton's law hold? If it holds at different points. What do I do? Where does the car go? Fine. If so many forces are acting at different points of a body, what do I do? How do I sum them up? Now this tells me that relax. Okay, you just relax. You sum all the forces. And assume that they are acting at a single point, the center of mass, which you have already calculated. Fine. So mass you know, the force you know. Now in the same direction, the direction in which the force is being applied, your body will be accelerated along that direction. That gives you the direction. And what is the magnitude? A is equal to F upon m, where m is the sum of all the masses. M is sum of all the masses. Now what happens? Suddenly it's a big relief for us. Had this not been happening, I would have been stuck. And when we are talking about a system of particles, we are not talking about 10, 50, 100, 1000, a million. We are talking about infinite number of particles. Infinite. And how would I have summed it had this not happened? Okay. So this is a big relief. The more you will understand the relief, how it is a big relief, the more you will appreciate this equation. There was a big trouble. And the trouble was, we were taught the center of the point masses, and there was nothing like a point mass, right? There is nothing like a point mass. Whatever masses you see in this world, they are all distributed masses, right? It never so happens that you are able to build a car where all the mass is at one point and everything else is absolutely light. And by light I mean absolutely massless and weightless. It never so happens. It will never happen that way. So when I had to extend my Newtonian laws, I had to go to the system of particles, and everything had seemed to be crumbling had this not come to your rescue. Okay? It is that significant an equation. Okay? So the center of mass of a system of particle moves as if all the mass of the system was concentrated at the center of mass and all the external forces were applied at that point. Is it not? Hmm? This is what this tells. So the center of mass moves in the presence of multiple forces in such a way that all the mass was concentrated at that point. All the mass was concentrated at that point. And the resultant of forces was acting at that point. So a multi-particle, a multiple particle system has been converted into a single particle system. This is the crux. In fact, I'd love to write that. Does a multi-particle system can be seen can be converted into a single particle system. Fine. Hope you people had written that. Seems as if the sum total of which the center of mass gets accelerated, right? So that's a big relief for us. Now, we just saw that we have come across something like this. Okay. So the resultant of all the forces acting at the center of mass, all the mass concentrated at the center of mass, and the center of mass accelerating due to one force in one direction. Fine. So everything, all those infinite number of particles, they collapsed into one particle. Now it has got some interesting applications, right? So what happens if F external is 0? If F external is 0, then what happens? M into A is 0. Now that means that A is 0. Okay. So the acceleration is 0. It means the motion is uniform. Okay. Thus, the motion is a uniform motion. The motion of what? The motion of the center of mass. Is or follows a uniform motion. Okay. Now let us try to understand. Suppose an explosive was thrown, okay, at an angle, right? So all the shells that you fire at longer distances, they are like that. Now what happens? What happens is that this shell was kind of moving like this, and suddenly when it came here, it exploded, say into 3 pieces. Okay, fine. So it got split into 3 pieces, and they flew off in 3 other directions. Now what was the force that was there in all the 3? The forces were all internal. It suddenly was the gunpowder suddenly got ignited and it exploded, right? Now what happens? What would have happened had that explosion not occurred? The particle would have followed this trajectory, right? A parabolic trajectory. Now when they are flying off, and since the external force is 0, what happens to their center of mass? It moves as if nothing has happened. You understand? So the center of mass still keeps moving along this. So center of mass continues moving along that direction, while all those 3 pieces are flying off in whatever direction they have gone.
Only if F external is 0.
Only because F external is 0.
Center of mass को अगर आएगा
Huh?
वो भी तोड़ेंगे.
What?
Center of mass भी तोड़ेंगे ना.
No. Suppose one thing is gone there, another is gone there, another is gone there.
There's nothing left.
Huh?
There's nothing left.
Nothing is left. Or maybe even if it is left, if say some particle is left and that also starts accelerating in some direction, what happens? Maybe even if something is left, it is not essential that it will be moving with the same velocity and in the same direction. Okay.
But
So-
the center of mass moves with the same velocity.
But center of mass continues its journey as if nothing has happened.
And the center of mass of all these 3 particles that have been disintegrated will come out to be there only. Always.
They have to disintegrate like that. They have to be moving, they have to be so positioned that their center of mass is there and its velocity also remains as it would have been had it not split.
And if none of them both are matching, then an F external is applying on it.
So what happens if you are able to say C, you are able to check that 2 of the splinters are there, then and you understand that there will be three of them, then you will be able to tell where should the third where should the third be. When the police investigate the crime scene and you see in papers the ballistic investigation, it is actually this. If it's a bomb, ballistic investigation is this. If it's a bomb, fine. If it is bullets, then they try to find out. Then it must have been there. There is a mark of bullet on that wall in that direction. So it means that bullet must have been fired from here at this distance, at this angle, so that it'll damage the plaster like that. No. If it is shot vertically, what happens? It goes and gets stuck, or maybe ricochets and falls down. And if it is hit obliquely, what happens? It takes out a bigger chunk of plaster. So many things. Okay, but they are so maybe they find 2 pieces of a bomb here, then they'll be able to tell that this is a so and so make bomb and mass is so much, then the third must have gone in what direction or whatever, right? So they have to understand these concepts. Okay, I don't know how many of them are actually conversant with it, but this is how it works. Correct? We understand that? Fine.